Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear student, I hope you are fine. Today I want to discuss about some mathematical problem, which is chapter number H.C. Now, mathematical problem. Our first mathematical problem is question number example 3. A light rod is acted on by three parallel forces P, Q and R acting at 3 points, a distance 2, 8 and 6 meter respectively from one end of the rod if the rod is in equilibrium, so that P is to Q is to R equals to 1 is to 2 is to 3. For this math, firstly, we can draw this figure which will be very helpful to understand. Look at this. Suppose AE be a light rod, and here three parallel forces P, Q and R are acting at point B, D and C with distance AB equals to 2 meter, AD equals to 8 meter and AC equals to 6 meter respectively from the point A. So now we can write here, let AE be a light rod and three parallel forces and three parallel force P, Q and R are acting at point here, look at this, at point B, D and C. B, D and C with distance here AB equals to 2 meter and AD equals to 8 meter and here AC equals to 6 meter respectively from the point A. Now look at this. Now here BC equals to AC minus AB equals to, here look at this, AC equals to 6 meter, so we can write here 6 meter minus AB equals to 2 meter, so 6 minus 2, it will be 4 meter. And another one is here CD equals to here AD minus AC. Here AD equals to 8 meter, so here 8 and AC equals to 6 meter, so 8 minus 6, it will be 2 meter. Now after this line, we can write here, since the force are in equilibrium, okay, hence the resultant Hence the resultant of force are P and Q. Here P and Q be R, which is equal but opposite direction. Okay, that's why we can write here R equals to P plus Q. That's why we can write here R equals to P plus Q. Look at this. This is how we got it. Look at this here. P and Q. These are two forces and same direction, and these are like parallel force. That's why the angle of P and Q is 0 degree. So we can write from parallelogram law of force. We can write here R equals to square root P square plus Q square plus 2PQ, and here cos alpha. Alpha means angle means here 0 degree. So we can write here P square plus Q square plus 2PQ, here cos 0 degree. So we know that cos 0 degree is 1. So we can write here P square plus Q square plus 2PQ, and here P square plus 2PQ plus Q square, it will be square root P plus Q whole square, and here square root and square, it will be cancelled. So that's why P plus Q. That's why, look at this, here R equals to P plus Q. That's why R equals to P plus Q. Now after this line, here R equals to P plus Q, and look at this, here P into BC, and here Q into CD. Look at this, here BC and CD are equal. Here P into BC equals to Q into CD, and here the value of BC equals to 4. That's why P into 4 equals to Q into CD. CD equals to 2, and after this line we can write here 2P equals to Q, and here R equals to P plus Q, equation number 1, and 2P equals to Q, it's equation number 2. Now after this line, here we can write here from equation 1 we get, look at this, R equals to P plus Q, but here Q equals to 2P. So that's why we can write P plus Q equals to 2P. So P plus 2P, so it's 3P. Here look at this, R equals to 3P, here Q equals to 2P, and now we can write here P is to Q is to R equals to, here P means P is to Q equals to 2P, Q equals to 2P, and here R equals to 3P. So After this line, we can write therefore 1:2:3. This is the required answer of question number example 3. Now example number 7, which is credit question. Here ABC is triangle. Answer the following question in light of picture. Question number A. 3 like parallel force PQR are acting at the angular points of the triangle stated on the stem. If the resultant of the forces in any general direction passes through the centroid of the triangle, then prove that P equals to Q equals to R. And now question number B. Two ends of ACB rope of the triangle stated on the stem attached at points A and B, which lie on same horizontal line. A body with weight W knotted at point C belongs to the rope. If the length of sides of the triangle are A, B, C and its area is del means area, then show that the tension of part CA of the rope is equal to WB by 4C del means area into C squared plus A squared minus B squared. Now question number A of example number 7. Here look at the figure. Here G is the center of triangle ABC. So we can write let the centroid of triangle ABC be G. And here look at this. There are three forces P, Q, R. Here three forces P, Q, R act at point A, B, C. A, B, C of triangle ABC. Here look at this. Here since the resultant of force passes through the point here look at this, passes through the point G and force P act at point A. Here the resultant of like parallel force Q and R. The resultant of like parallel force Q and R act at point B and C. Look at this. B and C must be must be acted along the line of action, along the line of action, like the lines AD and BC, AD and BC. Okay, here AD and BC. Look at this. After this line, we can write here. After this line, we can write after this line here. Moreover, here since, look at this, since D is the common point of this line, so we can write the common point, common point of the line is D. Hence the resultant of force Q and R, hence look at this, the resultant of force Q and R, hence look at this here, act at point D, so that's why we can write here, look at this, Q into BD equals to, and R into CD, and look at the figure here, AD is the median, so AD is the median and D is the midpoint of BC. That's why BD and CD are equal. So we can write Q equals to R here BD equals to CD, because D is the midpoint of BC and AD is the median. And now similarly by drawing the median, by drawing the median from C, look at this, from C upon the line AD, it could be proved that P equals to Q, which is equation number 2, and this is the equation number 1. Here this is the equation number 1 and this is the equation number 2. Now from equation 1 and 2. Now from equation 1 and 2. Now from equation 1 and 2, we get P equals to Q equals to R, which is the. Now question number B. Here look at the figure. If W weighted body noted at point C of roof ACB, then W will be acted horizontally below from point C and perpendicular upon the base along CE. So the tension at two ends of the roof are different. Let the tension of the roof along CA and CB be T1 and T2, and here AB side of triangle ABC would be parallel to the base, and we are to draw the line, LCM, which is parallel to AB, and here hence force W, T1 and T2 are in equilibrium at point C. Look at this, here three force W, T1 and T2 are in equilibrium. So that's why we can apply Lami's theorem. So we can write here, look at this. Now by Lami's theorem, we get, look at this, here force T1 by sine, so angle will be BCE, sine angle BCE equals to, when force T2, here T2, then sine angle will be other two force, angle of between other two force, here W and T1. So we can write here, it will be sine ACE equals to, and here W force, and we can write sine the angle of ACB, and now here from this two part, T1 by sine angle BCE and W by sine angle ACB. So here we can write T1 by sine angle BCE equals to, here W sine angle ACB, and after this line we can write here, here look at this, angle BCE, so it will be angle 90 degree plus BCM, and here BCM, angle BCM equals to angle ABC. That's why we can write here, T1 by sine angle 90 degree plus angle ABC, because here angle BCM equals to ABC. Okay, here equals to W by sine ACB. Look at this, sine ACB. So it will be sine ACB, and here look at this, we can write 90 degree. 90 degree means 1 into 90 degree. 90 degree means ABC. Here 1 into 90 degree. Here look at this, 1 is odd number. So that's why we can write, operator will be changed. So cos angle ABC, and here T1 and W by sine ACB. Now after this line, here cos ABC means cos B, T1 by cos B equals to, here W by sine ACB. Sine ACB means sine C, and here all we know that the formula of cos B, here cos B equals to minus B square c square plus a square by 2ca, and area of triangle ABC, area of triangle ABC, here del equals to, look at this, 1 by 2 AB sin C. That means sin C equals to 2 del by AB. Now after this line we can write here, after this line, T1 by cos B. Cos B means cos C square plus A square minus B square by 2ca. So we can write C square plus A square minus B square by 2ca equals to, here W by sin C. Sin C means 2 del by AB. 2 del by AB. And from these two parts, A and A, they are cancelled. So we can write T1 by C square plus A square minus B square by 2c equals to W by 2 del by B. And here, after this line, therefore after this line our answer will be T1 equals to after this line WB by 4c del means area, del into C square plus A square minus B square, which is the required solution of question number B.